Hello, this is Marion Smith. In this video, I would like to talk about some of the elements of an ERD, and in this way, we should cover most of the vocabulary of the ERD. ERD stands for Entity Relationship Diagram. In the graphic before you, we see an example of an ERD. Now, an ERD is a conceptual model that represents some ideas that one might have about the use of data. So let's talk about the elements of the diagram in front of you. In this diagram, we see an example of two entities. Recall that an entity is, at least in my definition, it's some type of object that is a person or a place or a thing. And in an ERD, we represent an entity as a rectangle. And in this diagram, we have the name of the entity in the upper half, or the upper portion of the rectangle. In the lower portion of the rectangle is a list of what is known as the attributes of an entity. An attribute is simply a characteristic of the entity. So for EMP, which stands for employee, we see we have two attributes, ENO for employee number and ENAME for employee name. And for the project entity, we see we have PNO as a project number and PNAME for the project name. In our relational, not relational model, but our ERD, our entity relational diagram, we designate one or more attributes as what is known as the primary key of the entity. It's just a unique identifier for the instance of that object. So we're all familiar with the concept of an employee number that is associated with every unique employee in an organization. Now, associated with these two entities is a relationship. A relationship is simply an association between entities. And in this case, our relationship is named assigned. So, in this graphic, we discuss what an entity was, the definition of an attribute, and the definition of a relationship and how they're designated. Rectangles. A relationship is indicated by a line joining in some fashion the two entities and the name of the relationship. Now, one of the reasons why I wanted to go over these definitions associated with the ERD is because when we use an ERD to create a relational schema, like we're going to use this as a basis for a relational database, the algorithms that are known, where you take an ERD and use it as a basis for a relational schema, there are some algorithms out there that kind of give you a step-by-step approach in taking the ERD to a relational schema, and that algorithm uses this vocabulary. So this is why I was going over the vocabulary. So on an ERD, you should be able to identify by the diagramming conventions that are used whether an entity is a strong entity, and we'll discuss what all these items are, whether it's a binary 1 to n or m to n relationship, whether it's a weak entity, whether the relationship is an identifying relationship, whether the weak entity has a partial key or not, if an entity is associated with total participation, whether an entity has an attribute that's a multi-valued attribute, and whether a relationship among entities is it consists of more than two, or N-ary relationships. So here we have an example of a very simple ERD, two entities and a relationship between them. And I wanted to point out that in this diagram we have what is known as examples of strong entities, and this is considered a binary M-to-N relationship. So how do we know it's a strong entity? Each entity has a primary key. So again, the primary key is indicated by the underlined attribute. So both entities have underlined attributes to indicate primary keys. You can have an ERD where you have an entity without a primary key. It may be a partial key or maybe no key at all. But when we see an underline in an ERD, we know it's a primary key. Now we know this is a binary M-to-M relationship because binary means two and two entities in this case. And the conventions of the tool I use to draw this, these crow's feet, called the crow's feet notation, is interpreted as many. So we say an employee can be assigned to many projects, and a project can have assigned to it many employees. So it's many to many. Now here's an example of an ERD with a weak entity. So in this example, we do not have an underlined attribute in the entity budget, for example. So we have this dotted line. This indicates that this budget entity does not have a primary key. It has what's known as a partial key. And the partial key is used to identify how that budget instance is related to the project in this example. So what does it mean to be a weak entity? A weak entity means that the entity cannot stand alone. So the budget can't exist unless we have a project. So a budget has to be associated with a project. Cannot exist without a project. Can't have a budget for something unless you know what that something is. In this case, it's a project. And when we have a weak entity, the nomenclature is that the relationship name is considered what is known as the identifying relationship. So a project has a budget. So a budget is identified by the project that has the budget. Seems like we're going around in circles, but I think it's almost obvious what this means. Okay, so every weak entity has to have an owner. Something has to own the budget because it can't exist by itself. What owns the budget? The project. So the project entity is called identifying or owner entity. And let's see, what other vocabulary we have here. We talked about the identifying entity, the identifying relationship. I think I listed it twice. And we have some indication here of what's called a total participation constraint. How do we know that that's there? Okay, so the double rectangle refers to a weak entity. The double diamond refers to the identifying relationship. And then we have these double lines here to indicate the relationship between project and budget. So all this double stuff kind of hits you in the face here that this is just not a normal relationship between two entities. You have a weak entity, an identifying relationship, and then the double lines refer to the total participation constraint. What that means is that for every budget, there has to be a project. That's what this double line means. So every budget has to participate in a project, and just to make it interesting, I said that every project has to participate in a budget. Can't have a project unless there's a budget, so it goes both ways. Let's see. I'm trying to decide if I hadn't made any sense by having the double participation here, but let's move on. Alright, here's a diagram that has a one-to-one relationship illustrated. One-to-one relationship. This is a binary one-to-one relationship, meaning we have a binary meaning two entities, and the one-to-one relationship means that for every instance of employee, we can only have one spouse, and for every spouse, we can only have one instance of employee. Oh, I wrote it down. An employee has 0, 1 spouse. That's that optional designation here with using this notation that is hard to see. And it turns out that spouse is also a weak entity because you can't associate a spouse with no employee. It has to be associated with employee, at least in the way this is defined. Notice that spouse, gee, I underlined this, so it does show that it has a primary key, but it doesn't necessarily, and we shouldn't interpret that as a primary key, because if spouse can't stand alone, where the name is the identifier, because of course we all know that different people can have the same name, so a name does not uniquely identify the spouse. So here we see, for example, spouse does not have its own primary key. Yes, this can be confusing, I agree. One-to-N relationship, here we have an example where a title is given to many employees. And in this case, an employee has a title, has to have a title, according to this notation that I'm using, and a title is given to 0, 1, or more employees using this notation. Title is given to many employees. So 1 to N. Alright, let's see what else. Sometimes when we look at ERDs, we have what is known as a multi-valued attribute. And I just put a double circle around the attribute in this example, members, that could be multi-valued. So if you have a project and you have a lot of people working on it, you can make members as an attribute that describes the project. And members would consist of all the people associated with that project. So if there's more than one, it has to be what is known as a multi-valued attribute. Now here's an example of a N-ary relationship. And that just means that you have a relationship that involves more than 2 entities. So my interpretation of this diagram is that employees are assigned to a project location, where employees, or employee, excuse the typo, an employee is assigned to a project and its location, because it could very well be that a project involves many employees in many different locations. And with that in mind, I hope this reviewed some basic vocabulary. Thank you.